These are our notes for our thermal energy calculations. So we're going to start with the equation for thermal energy. So thermal energy is going to be represented by this Q. Okay, so thermal energy is going to equal my mass times my change in temperature, so delta T, times my specific heat, which is represented by a C. I'm going to write this out a little bit longhand. So my thermal energy is going to equal my mass times my temperature final minus my initial temperature times my specific heat. So in this equation, Q equals thermal energy, and we're going to measure that with our units being joules. My mass, so the M is my mass. We measure mass using kilograms, that's my units. TF, that's our temperature final. That's the ending temperature. And we are going to measure that in degrees Celsius. My TI, that stands for temperature initial. That's my starting temperature. We're going to measure that in degrees Celsius. And then my C is my specific heat. This is individual, so this is going to change with whatever material you're measuring that temperature change in, or that thermal energy in. And the units for specific heat are joules per kilogram times degrees Celsius. Okay, so this is our original equation. I'm going to run through how to change it if you want to find mass, a temperature, or specific heat. So first we're going to start with finding the mass. So our thermal energy equals our mass times our temperature final minus our temperature initial times our specific heat. If we want to know what the mass is, we need to get it all by itself on the equal sign, kind of like that thermal energy is. So to do that, what we do to one side of the equal sign, we have to do to the other. If something is in the numerator, if we write it in the denominator on that side, that's like saying it's 1 over 1. They cancel each other out. It equals 1. Or 2 over 2. If it's on the top and the bottom, we can simplify that down to 1. Same thing with these. If it's on the top and the bottom, we can simplify it to 1. Anything times 1 is going to be that number itself. Okay, so we have our equation. We want to get rid of these. So we're going to divide this side by our temperature final minus our temperature initial, and by our specific heat. Because we did that to this side, we have to do it to this side. Okay, so on this side, this is going to cancel, and this is going to cancel. So we're left with just our mass. So our mass is going to equal our thermal energy divided by our temperature final minus our temperature initial times our specific heat. Notice that this is in brackets, so we have to do this subtraction before we do any of those. You need to write this equation down in case you need to use it for some of your problems later. Okay, so let's say we want to find our change in temperature. Okay, so we're going to start with our original equation. Our thermal energy equals our mass times our temperature final minus our temperature initial times our specific heat. So we want to get this all by itself. So I'm going to divide this side by my mass times my specific heat. Because I do it on this side, I have to do it on this side. Okay, my mass cancels, my specific heat cancels, and I've got my thermal energy over my mass times my specific heat equals my temperature final minus my temperature initial. So then, if I want my temperature initial, I'm going to subtract my temperature final. Okay, so I can take this side minus my temperature final. If I do it on one side, I have to do it on this side, minus my temperature final. And then we'll get my specific heat divided by my mass times my thermal energy divided by my mass times my specific heat minus my temperature final. That's going to equal this, equals negative temperature initial. Okay, and so when you get your number, just make sure that you're cognizant of that negative sign. If we want to get temperature final, we're going to add, instead of subtracting temperature final, we're going to add temperature initial to this side. And so then we will have to add temperature initial to this side. So this now becomes an I, that becomes an F, this negative sign goes away. And so we have our thermal energy divided by our mass times our specific heat, plus our temperature initial is going to equal our temperature final. Again, you should have these equations written down. Okay, and then if we want to use this equation to find our specific heat, we can solve this equation like this. So my thermal energy equals my mass times my temperature final minus my temperature initial times my specific heat. I want this all by itself, so I'm going to divide this side by my mass times my temperature final minus my temperature initial. Okay, what I do on one side, I got to do on the other side. Okay, this is going to cancel, this is going to cancel, that'll cancel, that'll cancel. I have that all by itself, and so my equation is specific heat equals my thermal energy divided by my mass times my temperature final minus my temperature initial. Okay, and so those are those equations that you want to have written down to help you when we start doing our actual problems. Okay, so these are our practice problems for thermal energy. We need to do those 5 steps that we've done for all of our solving of the equations. So example 1, we're just going to run through some examples. The temperature of a 32-gram silver spoon increases from 20 degrees Celsius to 60 degrees Celsius. If silver has a specific heat of 235 joules per kilogram times Celsius, what is the change in thermal energy? So our first step is underline the question. What is the change in thermal energy? So we're looking for thermal energy. Our variable for thermal energy is Q, so that's what we're looking for. Now we want to write down all of our other variables. So our mass, right here, our mass equals 32 grams. Our temperature increases from, so our initial temperature is 20 degrees Celsius to 60 degrees Celsius. So our temperature final is 60 degrees Celsius, and it has a specific heat, that is our C, of 235 joules per kilogram Celsius. Now remember, we need this in kilograms before we start, so we need to convert that. So we have King Henry died by drinking chocolate milk. Our grams is our base unit. We need to get it here, so we're just going to move our decimal 1, 2, 3 spots. So it's decimals here, 1, 2, and we add another 0. So that's going to equal 0.032 kilograms. Now we're ready to start calculating. So we underline the question, we wrote down our variables. Now we have to write the equation that we need. We're looking for Q, so this formula up here, that's what we're going to use. So we write down our formula without any numbers in there. Our thermal energy equals our mass times our temperature initial minus our temperature final times our specific heat. So now we just plug these in. Q equals 0.032 kilograms, that's our mass, times our temperature final, which is our 60 degrees Celsius, minus our temperature initial, which is our 20 degrees Celsius, times our specific heat, which is 235 joules per kilogram Celsius. All right, so the first thing we want to do is we want to do this part, okay? So 60 minus 20, that's going to give us 40 degrees Celsius. We're going to multiply that by our mass, by our 235 joules per kilogram Celsius. Okay, and so when we put this into the calculator, what we end up getting, now we can just plug them in, doesn't matter the order, we end up getting 1,460, holy cow, okay, I'm looking at the wrong one. When we put this into our calculator, we get 0.3008 joules, okay? Then we need to do our significant figures. So when we look at our significant figures, when you do this, you are not using this. Not used for sig figs. So this is our constant. Our specific heat is a constant. So it is not used for significant figures. So when we want to do significant figures, we look at these three measurements. This has 2 sig figs, this has 1, this has 1. So we need 1 sig fig. We get 0.3 joules for our thermal energy. Example number 2. Okay, 38 grams of a substance with a specific heat of 250 joules per kilogram Celsius is heated from 26 degrees Celsius to 180 degrees Celsius. Calculate the change in thermal energy. So we want to underline the question. We're calculating the change in thermal energy. So when we write our variables down, that's what we're trying to find. When I read my problem, 38 grams of a substance, so my mass is 38 grams. It has a specific heat, so C is my specific heat, is 250 joules per kilogram Celsius. It is heated from 26 degrees, so from means that's my temperature initial. Temperature initial equals 26 degrees Celsius to 180. My temperature final is 180 degrees Celsius. So then after I underline my question, write down my variables, I need to write out my formula. So Q equals my mass times my temperature final minus my temperature initial times my specific heat. Now I just need to plug these in. Careful of our units. We need to convert that to kilograms, so we're going to move our decimal again, and that's going to equal 0.038 kilograms. So when I plug that into my equation, Q equals 0.038 kilograms times my temperature final is 180 degrees Celsius minus my temperature initial, which is 26 degrees Celsius, times my specific heat, which is 250 joules per kilogram degrees Celsius. Okay, so the first thing I want to do is I want to subtract this part out. Okay, that's in brackets, so that's the first thing we do. So Q equals 0.038 kilograms times 180 minus 26 is 154 degrees Celsius times my 250 joules per kilogram Celsius. Okay, and so since this is in the denominator and these are in the numerators, these would cancel out, and the unit that I'm left with is joules. So when we put that into the calculator, we get 1,463 joules. We need to check sig figs. So when we go over here, remember our C, our specific heat, that is a constant. So we don't look at that for our sig figs. We look at our mass and our temperature. This has 2 sig figs, 2 sig figs, 2 sig figs. My answer needs 2 sig figs. And so my thermal energy equals 1,500 joules. That would be my answer. Okay, example number 3. So a 500 gram block of metal absorbs 5,016 joules of heat when its temperature changes from 20 degrees Celsius to 30 degrees Celsius. Calculate the specific heat of the metal. So we're looking for specific heat. That's our C. Okay, what other things do we have? Our mass is 500 grams. Our thermal energy is 5,016 joules. And our temperature initial changes from 20, so 20 degrees Celsius. And our temperature final is our 30 degrees Celsius. Okay, so this is where we're going to have to use one of those other formulas, right? We need to have C all by itself. So that would be this formula right here. So we're going to write that formula down. Our specific heat equals our thermal energy divided by our mass times our temperature final minus our temperature initial. Okay, so now I need to go over and I need to see if everything's in the proper units. This is in grams, so I'm going to need to change it to kilograms. So we did that earlier. We're moving our decimal 1, 2, 3 spots. So 500 grams equals 0.5 kilograms. Okay, so now we just need to plug these into our equation. So C equals Q, which is 5,016 joules, divided by our mass, which is 0.5 kilograms, times our temperature final, which is 30 degrees Celsius, minus our temperature initial, which is 20 degrees Celsius. So C equals 5,016, and 30 minus 20 is 10 degrees Celsius. That's that part right there, times 0.5, which is half. So this is going to equal 5. So 5,016 joules divided by 5 and that would be what, kilograms Celsius. Okay, and so when we take 5,016 divided by our 5, our specific heat, we get 1,003.2 joules, that's on top, per kilogram times degrees Celsius. And then we need to check our sig figs, right? And so all of these are measurements. So there's one sig fig here. We're going to have one sig fig. Okay, so that's going to equal 1,000 joules per kilogram degrees Celsius. Okay, and then finally we have example 4. So a bottle of water with a mass of 500 grams absorbs 2,300 joules of thermal energy from sitting out of the refrigerator. If its temperature was initially 5 degrees Celsius, what would the new temperature be? Okay, so what will the new temperature be? We have the initial temperature. So we want temperature final. Okay, that's what we don't know. Our temperature initial was our 5 degrees Celsius. Our mass, right here, our mass equals 500 grams. Our thermal energy, that's our Q, equals 2,300 joules. And our specific heat, we're going to have to use, so it doesn't say it in the problem. If we don't have the specific heat in the problem, we're going to use our table. So for this one, I put the table on here. Some of them you'll have to get out of your book on page 160. So our specific heat of water is 4,200. Okay, so that is 4,200. So now we're going to use this formula. Our thermal energy divided by our mass times our specific heat is going to equal our temperature final minus our temperature initial. Okay, so this is the easiest way to do this, is to just plug your numbers in this way. Okay, so Q equals 2,300 joules divided by our mass. Our mass is in grams, so we need to convert that. 0.5 kilograms. So 0.5 kilograms times our specific heat, which is 4,200 joules per kilogram Celsius. So 4,200. Okay, trying to pick up where we left off. My phone ran out of memory. So we have our 2,300 joules divided by our 0.5 kilograms times our 4,200 joules per kilogram Celsius. And so when we divide that out, we get 1.095238 is going to equal our temperature final minus our temperature initial. We know that our temperature initial is 5, so now we're going to plug that in. Okay, so this last one, kind of having some trouble with my phone. But when we put this in the calculator, we get 1.095238 equals my temperature final minus my initial. I'm going to put my initial temperature in for my temperature initial here. So if I add 5 to this side, I can get rid of my temperature initial on this side. Have to do that to the same on this side. So my 5 plus my 1.09 gives me 6.095238 degrees Celsius. I have 1 sig fig, so this needs to be 1 sig fig, and I get 6 degrees Celsius for my temperature final.